Hello, this is checkpoint 2.58. They want us to plot the spherical coordinate point 2, negative 5 pi over 6, and describe its location in both rectangular and cylindrical coordinates. So let's first identify this point, 2 minus 5 pi over 6 and pi over 6. And let us mark these as rho, and the next number is theta, and the last number is phi. And what we want to do is we want to try to see how that looks like on the XY plane. So let's draw the axes, or not the XY plane, but an XYZ space. All right. Rho is a radial distance. We'll try to see. We'll probably identify that last, and theta and phi give some sort of direction. To get phi, or to get theta, well, let's look at it on a two-dimensional XY plane, and negative 5 pi over 6 is going in the negative direction. It's almost at pi, except it's short by pi over 6. So negative 5 pi over 6 is happening in the third quadrant. So let's try to draw the third quadrant, which is going to be behind here, and an angle of 5 pi over 6 would be something that goes there. And let's label this as theta is equal to negative 5 pi over 6. Okay, we have the theta. Our phi is going to be an angle from the positive z-axis that drops down. So from the positive z-axis, that would drop down an angle of pi over 6. So that's not very long. And it's happening right above the angle that we just saw. And so this, will label this phi equals pi over 6. And then finally, our rho. The rho is going to be a distance from the origin to the point that we're talking about. So I'll say rho is equal to 2, and that is just really the length of that line segment from the origin. So we can describe this point as being a point above the XY plane, so it's in the first 4 octants, and if we look at it in quadrants, it's in the third quadrant, and so that would be equivalent to the third octant because it's above the XY plane. Alright, that's where the point is, and now let's see if we could do some translations. We're going to try to remember our formulas for X, Y, and Z in spherical coordinates. So X is going to equal to rho sine phi cosine theta. And a good way to remember, well, let me write down the second one first. Y is equal to rho sine phi sine theta. So what I was saying is that a good way to remember is that this is similar to polar coordinates or cylindrical coordinates, because x is equal to r cosine theta, y is equal to r sine theta. So that means r is equal to rho sine phi. And so that's, you can think about this as r cosine theta and r sine theta. Alright, our third one is z, and that's equal to rho cosine phi. Okay, so theta is going to be theta, so that's not necessary to translate. And let's do our translations. Let's figure out what r is equal to. R is equal to rho is 2 times sine phi. Phi is pi over 6. And this is going to be sine of pi over 6 is 1/2. So r is going to equal to 1. That would be a 1. Okay, that is the r in cylindrical coordinates. And we also need the z in cylindrical coordinates, so we can figure that out here. Z is equal to rho, which is 2 cosine phi, and phi was again pi over 6. And cosine of pi over 6 is root 2 over 2, or root 3 over 2. And so we get z is equal to square root of 3. Okay, so our spherical coordinates is this point, and we can now write down our cylindrical coordinate point. Cylindrical coordinates, and that's going to be given by r, which is 1, theta, which is going to be the same, and our z, which is square root of 3. Okay, now to get the rectangular coordinates or Cartesian coordinates, we need to figure out a couple more things. We need x and y. So x will equal to rho sine phi times cosine theta. So we have 2 times pi over sine of pi over 6 is 1/2, and cosine of 5 pi over 6, this is 5 pi over 6, reference angle pi over 6. A cosine is root 3 over 2, and it's in the third quadrant, so it's negative. So this is going to be negative square root of 3 over 2, and the 2 and the 1/2 would cancel. That gives us with just a negative root 3 over 2, and your y is equal to 2 sine pi over 6. This time we have a sine minus 5 pi over 6, and the sine of that is 1/2. The reference angle is pi over 6, the sine of that is 1/2, but it's in the third quadrant, so it's negative 1/2. And that makes sense because it looks like the x and the y should be negative, so we have negative numbers for the x and the y. The z is positive, it's above the xy plane, so we are in fact in the third octant. And then your Cartesian coordinates, or rectangular, is going to be given by x, negative root 3 over 2, y, negative 1/2, and z, square root of 3. Okay, that's it. I hope that helps.